This is the third recorded lesson for the unit on homeostasis and the plasma membrane for students in Ms. Stout's biology class at Limestone Community High School. We already talked about the parts of the plasma membrane in the previous two lectures, but again I wanted to show you another diagram of the fluid mosaic model, which remember does represent what the plasma membrane looks like. Now down here you can just look at the key, which is fine, but I also want you to start becoming familiar with actually looking at the fluid mosaic model and being able to recognize the similarities between each of the different diagrams that I've shown you, and be able to pick out the parts that you'll need to know. So again, remember that the plasma membrane is described as a bilayer. So we've got one, we've got two, so a bilayer of lipid molecules, and specifically they are called the phospholipids. And this marker kind of doesn't work that great. Phospholipids. Sorry, that's hard to read. Phospholipids. And then extending all the way through the bilayer are going to be the membrane proteins, and you can see that there are different shapes. Remember, those different shapes are going to be related to the different types of chemicals that would be matching those shapes and would be allowed into or out of the cell. And then we know that this part is the inside of the cell because this is going to be representing the cytoskeleton. Remember, the cytoskeleton are going to be your microtubules and microfilaments that just allow support for the plasma membrane and the other organelles in the cell. And then not as plentiful as the phospholipids, but they are still within the same bilayers, are going to be another type of lipid molecule. Remember, a lipid is a fat. Another type of lipid molecule known as cholesterols. And remember, those are responsible for giving the plasma membrane stability and support, while the lipids, the phospholipids, keep it pretty fluid. Now, as I've said, the cholesterol lends support, but the phospholipids keep it fluid. Cholesterol is going to be more of a solid fat, whereas the phospholipids are going to be more of a liquid fat. Who cares, right? Well, there is an importance for both of those saturated and unsaturated fatty acids in your plasma membrane. And you might have heard of saturated and unsaturated fats maybe if you're in health class right now. And their physical properties are important to know because that leads to how they're important in your plasma membrane. First of all, your phospholipids can be made up of either one, saturated or unsaturated fats. And when you take MPS next year, or if you go into chemistry, you will learn more about the chemical structure of saturated versus unsaturated fats. Whoa, that went fast. Membranes with more unsaturated fats are going to be more fluid. So these are what are known as your good fats. It's important for your membrane to maintain fluidity because some materials just have to be able to pass directly in between those phospholipids. They're not actually going to use a membrane protein. So if they're fluid, it's going to be easier for them to move through. When you're thinking of food-wise, your unsaturated fats are going to be those that are better for your body. Another reason why this is important for our membranes is because your unsaturated fats, like I said, they are liquid, but they also stay liquid at even really low temperatures. Okay, who cares? Well, this essentially is how frostbite happens. Frostbite happens when the phospholipids no longer are fluid and they actually turn to solid, and those membranes lock up, and that doesn't let materials into or out of the cell. That's why we have to keep our nose and ears and fingertips and toes covered when it's super cold out, because we do have unsaturated fats in our membranes, obviously, but we don't have as many as, for example, an Arctic animal would. They are exposed to the elements all the time, but yet they're not always suffering from frostbite. And that's because they have a higher amount of unsaturated fatty acids in their cell membranes. There is a test question about frostbite. Why is this marker not working? That's annoying. Test. That says test right there. Question. So know that Arctic animals are going to have those unsaturated fats. Now, cholesterol is going to be a saturated fat, and that's kind of why cholesterol gets a bad name, because it is going to be solid, and it is going to obviously stay solid at low temperatures, but it's even going to be solid at the higher temperatures. Cholesterol, when it is in its solid form, when it's too much, this is what's going to be that clogs your arteries and things like that. But we do need cholesterol to give stability so that our membrane doesn't just kind of fall apart. So that's talking about the different types of fats that are in that plasma membrane, in that lipid bilayer. The other major part of the membrane are going to be those membrane proteins. Remember I said they kind of work like a lock and a key. The proteins have a certain shape that will match the key of the shape of a chemical. And they're very, very specific. Just like a key to get into your house is not necessarily going to work to get into your grandparents' house or your neighbor's house. The proteins themselves are actually what carry out most of the functions of the membrane, so they are pretty important. As I said, with how you can find which one they are on a diagram, is they are the parts that actually extend all the way through the bilayer, and so they are on both sides of the membrane. And there's a couple of different kinds of proteins. You can have carrier proteins and channel proteins, but they actually have 3 different jobs. Number 1, they are in charge of selective permeability. They determine which particles may pass. So if I was taking these notes, I would say selective permeability to my note packet. Remember, the more places you see this information, the more it's going to stick in your brain. So by determining which particles may pass, it is actually the proteins themselves that are in charge of selective permeability. So that's one job. Second job is that proteins may act as enzymes. The job of an enzyme is to regulate a chemical reaction. Regulate chemical reaction. They can speed up a chemical reaction, they can keep a chemical reaction going at a steady pace, they can slow it down, but they can actually do this on the outside of the membrane itself. So that's the second job, is to act as an enzyme. And the third job is they're kind of like an ID for your body. Your proteins act as markers to other chemicals. So for example, your white blood cells are always traveling around through your bloodstream, checking things out to find out what cells belong and what cells don't. Well, your proteins, your membrane proteins on your cells, are a way that they communicate with your immune system to say, hey, I'm a cell that belongs in the body. I'm a skin cell that's supposed to be here. I'm a red blood cell that's supposed to be here. But this doesn't always work the way it's supposed to. For example, arthritis. That's an autoimmune disease. Autoimmune diseases are when your body attacks itself. And this goes along with those proteins. It's when your body's chemicals or different cells in your body no longer recognize that your cells belong, and so they attack them and destroy them. So that is the end of recorded lesson number 3.